So,
recording started.
Okay, so we are now being recorded, and we'll go ahead and get started. It looks like I have a student with a question, but I don't see what the question is. So the student with a question, go ahead and type it in the chat box so that I can see what your question is. Just click on the chat button, and then there's a place to type in the chat box and click send. Okay, so this is the MAT 115 Financial Math webinar, and the objectives of what we are going to be covering in this webinar, there's find the future value and interest earned or paid for compound interest, find the monthly payment for an interest paid on a mortgage, and find the first 3 rows of an amortization table for a mortgage. So we're going to be covering those 3 topics, and I'll pause periodically. If I see questions in the chat window as we go along, I will address those as we go along in the webinar. Okay. Okay, so we're going to start with working with this compound interest formula and finding the future value of an investment or a loan that uses compound interest. So A stands for the future value, which is what we're trying to find. P is the principal amount, which is the amount of money you're starting with. The R is annual interest rate as a decimal. You always want to take your interest rate that they give you as a percentage and write it as a decimal before you put it into the formula. So if you have, for instance, a 7% interest rate, then as a decimal, that would be 0.07, because you're going to move the decimal point to the left 2 places. So to convert from a percent to a decimal, move the decimal point left 2 places. And when you do that, it changes the percent to a decimal. So that's what you need to do for this R number in the formula. And then N is the number of years that you're going to have this compounding happening, and times the number of compoundings per year. And I have this listed below right here. Normally you won't see annually because that's more of just regular interest, but semi-annually, that's twice a year. Quarterly is 4 times a year. Monthly is 12 times a year, and daily is 365 times a year. So that would be your number for M. So to find N, you're going to take the number of years times M, whatever that number is for M. Okay, so we're going to use this formula now in an example to show you how it all works. And if you don't have your calculator with you, you might want to take a minute and go grab your calculator, because some of what we're going to be talking about is how to use this formula on your calculator. Some people think you need a big, fancy financial math kind of calculator, but you don't. You can do these formulas with just a regular calculator. Okay, so we're going to do an example. This example, it says find the future value for an investment of $2,000 at 2.5% interest compounded quarterly for 3 years. So my P, which is the amount of money you start with, is $2,000. The R is 0.025 because we had to take our 2.5% and move the decimal point to the left 2 places, so to get our number for R. Now M is 4 because it's quarterly. That tells me going to happen 4 times a year. Okay? Then N is the number of years, which is 3, times the number for M, which is 4. So my N is 3 times 4, which is 12. And that goes, so we're going to take these numbers and put them in the formula that we just showed on the previous screen. Okay? So half the battle right there is getting the right numbers in the right places in the formula. Now we have to do our computations, which using the order of operations becomes super important here. I do not recommend typing all of this into the calculator all at once and then clicking equals, because there's a really good chance it's not going to work out, okay? Especially when we get to other formulas, it doesn't always work out. We're going to do this step by step with following the order of operations and writing everything down as we go. So the 0.025 divided by 4 is what we need to do first, because remember, in the order of operations, you need to do what's inside the parentheses first. And when I look inside the parentheses, I see addition and I see division. And you're always supposed to divide before you add. So we're going to take care of this 0.025 divided by 4. We're going to do that first. So that gives me 0.00625. So that's going to go in that spot in the formula. Now notice I wrote down everything that was on my calculator screen. I typed in 0.025 divided by 4 equals. The number I see on my screen is the number I write down. You don't want to leave off any numbers. You don't want to round to any place. We're going to write all the numbers down. Okay? So now I need to continue working on what's inside the parentheses. I see 1 plus this big decimal, so I'm going to go ahead and add those together to get this 1.00625. Okay, so now we have 2,000 times 1.00625 with an exponent of 12. When we follow the order of operations, we need to do what is exponents before multiply. So we need to take care of this exponent of a 12 before we can multiply. So we need to figure out how to type that into the calculator. Now, some calculators have a button that looks like this, like an upside down V, and other calculators have a button that looks like an X to the Y. Those are the most common 2 buttons that mean exponent. So you need to be really familiar with how that works on your particular calculator, because different model calculators might have different buttons. You need to make sure you know how yours works. So here's a test you can do to see how your calculator handles exponents. We know that 2 to the 3rd is 8. That's 2 times 2 times 2. So let's see if we can get our calculator to say this. If you have an upside down V, type in 2, that button, 3 equals, and make sure you get 8. If you do, then that is how you're going to type in your exponent. You do the upside down V and then the exponent, and you're good. If you have a X to the Y button, then you would do the 2 and then X to the Y and then 3 equals. See if you get 8. If you don't, if you're having trouble with this and you have some kind of button like this, maybe it looks a little bit different, try typing it in the other way. There's some calculators out there that you have to type the exponent first. There's not very many, but there are some. So you would have to do like 3 and then your exponent button and then 2. But if you don't get 8, then that's not the way to do it, okay? Now, if you can't figure out which button on your calculator is an exponent button, this is a good question to ask. And if you ask in the chat box, that's fine, or you can email your classroom teacher, that's fine. We need to know the model, make and model, just like a car. Make and model of your calculator. Is it Casio? Is it Texas Instruments? What's the model number? And we can look that up for you and tell you how that exponent key works. The other option is to Google that question. But it's really, really important that you understand how to get something like that typed into your calculator, okay? So once you have that figured out, you can move on to the next step, and that's where we need to take our number to the 12th power. So whatever exponent button you have, go ahead and type that in, the 1.00625 to the 12th, and that gives you 1.077632599. Notice again, I'm writing down the entire number that I see on my calculator. The only reason I stopped is because my calculator screen came to an end, so I had no other numbers to write. Otherwise, you know, you write everything that you see, because what happens if you don't? If you round here, then this number is not accurate, which makes this number not accurate. And if you round again, now you're rounding twice. So now you're like 2 degrees away from being accurate. And then if you round again in your final answer, then you rounded on top of rounding on top of rounding. Then every time you round, you're getting further and further away from the most accurate answer you can get. So you don't want to round until the very last step. So I have my 1.00625 to the 12th, and that gives me this number, which I then put into the formula. So now it's 2,000 times that big number, which gives me this on my calculator screen, and now I'm allowed to round to the nearest cent. You want to make sure you round to the nearest cent. And so that's $2,155.27. If you round along the way, you would get something different. It might be off by a couple of cents. You might end up with something like $2,155.33. And if you type that into my math lab as your answer, it will say it's wrong, and then it can be frustrating because you didn't do anything wrong. You follow all the steps correctly, but somehow you're not getting credit for the answer because your answer is off by a couple of cents. So if you don't want that to happen to you, really important, write down all the numbers, then round at the very last step. Okay? Now, that would be how much after the investment of $2,000 after 3 years. That's how much you would have. So the question is next, what is the total interest earned for this investment after the 3 years have passed? Well, you have $2,155.27, but you started off with $2,000, so you just subtract them, and you see that it's $155.27 that was earned in this investment. Now, if it was a loan instead of an investment, because loans also can be calculated with compound interest, then all of the calculations would be exactly the same. It's just instead of earning $155.27, you would be paying that. So if that was a $2,000 loan, you would be paying back $2,155.27. So you would be charged $155.27 interest. If that was instead of an investment. And is there someone on the line that doesn't have their phone muted? I thought everyone would be muted calling in, but I hear some background noise a little bit. So just a reminder that you can go ahead and mute your phone just to kind of keep the background noise out, okay? Okay, so I'll just go ahead and pause for a minute. I haven't seen any questions in the chat box, but before we move on to doing another type of problem, I thought I'd see if there were any questions along the way. Okay, well, I'm going to move on then to the next type of problem, and that is finding the monthly payments for a mortgage. So I have a mortgage for $120,000 at 5% interest for 30 years. And there is a table in your book on page 714 that will help you with answering this question. So on page 714 in your book, you would see this table, and the numbers along the top are the number of years that you would have the mortgage. So there's 5, 10, 15, 20, 25, and 30. And then the numbers along the side are the annual interest rate. So in this question, we have 5%, which is right here, and then we have 30 years, which is right here, and the two intersect right there. So what this tells us is that for every $1,000 that we have in the mortgage, we are going to have to pay whatever it says right there, and that's 5.36822. That's the number you see right there where I've circled in red, 5.36822. So for every $1,000 in the mortgage, that is what you would have to pay. Now, of course, you're not going to have a $1,000 mortgage, but they're saying for every $1,000. So how many $1,000 do we have? Well, you take 120,000, divide by 1,000, it gives you 120. So what we're going to do is take 120 times the number from the table. Notice again, I wrote the entire number. I did not round it or cut any numbers off. I wrote the entire number, and when you multiply the two together, that gives you this number, but you can now round to the nearest cent because that's our final step. In the final step, that's when you round to the nearest cent. Round to the nearest cent. That means you have to look 3 places after the decimal point because that tells you how to round. You see here I have my decimal is 168. So because of the 1, 6, I look 3 places, there's an 8. So that means I had to round up to 17. I had to round the 1, 6 up to 17 because it was an 8 after the 6. So when you round to the nearest cent, you actually have to look 3 places after the decimal to see what to do with that place that would be pennies. Do you round up or do you leave it the way it is? If 3 places after the decimal, it's a 5, 6, 7, 8, or 9, you round up. If it's 0 through 4, then you round down. Okay? So the table is very useful for this because all you have to do is take the mortgage, divide by 1,000, and then multiply that number times the number from the table that's in your book. Let's do another mortgage example. This one says, what's the monthly payment for an $85,000 mortgage at 5.6% annual interest for 15 years? Now, when we look at this table back here, the annual interest rates are all in 0.5% increments, We have 4%, 4.5%, 5%, 5.5%, 6%, and so on. But this example that we're doing now has an interest rate of 5.6%, which is not on the table. So if we can't go the easy way and just multiply times the number on the table, then we're going to have to use what's called a monthly payment formula. That's this formula right here. So we need this monthly payment formula. P is still the principal amount. That's the amount that we started with. R is the annual interest rate. Again, this would be in decimal form. And then T is in years. So in this example, my P is 85,000, rate is 0.056, and T is 15 for the 15 years. So we're going to take these numbers and put them into the formula. So it looks like this. Now again, we have to make sure we're following the order of operations to calculate all this. I would absolutely not type this entire formula into my calculator and then hit equals, because it's not going to come out. Your calculator is not going to understand what you're typing. It's not going to, what your calculator understands is not going to be the same thing as the way this formula is set up. So, because you can't type in like a great big fraction bar and that kind of thing. So don't type this whole thing in and then just click equals. It's not going to work out. What we need to do is follow the order of operations and do it piece by piece like we did the first formula, the compound interest formula. So in my numerator, I'm going to go ahead and do what's inside the parentheses first and divide those two numbers right here. And notice again, I'm writing down everything that's on my calculator. Put that right there in that spot. So now in my numerator, I'm just multiplying those two numbers together. Okay? And the denominator, again, following the order of operations, I have to do what's inside the parentheses first. So I have the numerator of this fraction is just 12, but I have to figure out what the denominator of that fraction is by adding those two numbers, the 12 plus 0.056, so I did that here. And then I also need to figure out what my exponent is, that 12 times 15. So I took 12 times 15 and got 180. So I'm doing all these in little pieces. First thing, 0.056 divided by 12. Then I'm going to take the 12 times 15 to get 180, put it in the, notice I keep rewriting the whole big formula. I know it's using up paper, but it keeps you from losing track of where you are, and it keeps you from forgetting something or losing, there's a lot of numbers here, and you don't want to lose track of all the numbers you have going on in this problem. So every time I calculate something, I'm actually rewriting the whole thing so that I can see, okay, I take this out and I put that there, and then I take out the 12 times 15 and I put 180 right there. And now I take 12 plus 0.056 and write 12.056. So with those calculations, it gives me this. Notice again, I rewrote the whole thing, and I have lots of numbers after my decimal point. I just stopped writing if the calculator came to an end. Then in my numerator, 85,000 times that great big decimal gives me this 396.666695. Okay, so again, write that entire thing in the numerator. Then I have, in my denominator inside parentheses, I need to do that division. So I'm going to take care of this right here. Gives me this 0.99535501. So that goes in that spot right there. So I'm doing this little piece by piece, writing down all the decimals, rewriting the whole formula as I go so that I can make sure I don't lose track of anything. Notice how with every step, it's getting smaller and smaller and smaller. It started off really big, but you don't do all of it at once. You just do little pieces at a time. Make sure you're following the order of operations. Now, my numerator at this point, I just have a number. My denominator, I have two operations. I have subtraction and I have an exponent, and you're supposed to use your exponents before you subtract. So I'm going to need to take this 0.99535501 to the 180th power. That's what I'm going to do next. And this is where your exponent button on your calculator either looks like this or looks like this. You're going to write that in to your calculator, 9953501, and then your exponent button, whatever that might look like, and then you're going to type 180 and equals and get a number on your calculator. So I use the exponent button on my calculator. Gives me this, 0.4325548881. That goes right in that spot in the denominator. So now all I have left to do is subtract those two numbers, and that gives me this big fraction here. Again, notice I am writing out all the decimals I see on my calculator screen. Go out as far as your calculator does. Then divide these two. Now all you're left to do is divide these two numbers. And to round to the nearest cent, I have to go 3 places after the decimal. Because this is a 9, that means I have to round the 0.03 up to a 0.04. So the monthly payments for this mortgage of $85,000 at 5.6% interest for 15 years, the monthly payment for the mortgage is going to be $699.04. Okay? So that, it takes us through the formula step by step. This formula, I just want to note that we used it to find the payment of a monthly payment of a mortgage. But this works for other installment loans as well, like car loans. An installment loan is a loan that's repaid over time with a set number of scheduled payments. If you have a car loan, you might have it for 4 years, and these are the payments that you make every month. So an installment loan could be a mortgage, could be a car loan. This formula that we started off with, way at the beginning, this formula right here can be used for other installment loans. A mortgage, it's used for car loans or any other installment loan. So it's good to know that if you run across other types of installment loan problems, and you need to know the monthly payments. Okay, so how much total interest is paid for this mortgage? Well, there's 12 payments a year, and it's a 15-year mortgage. So that means it's 180 total payments, and we made each payment of $699.04. So I'm going to multiply the monthly payment times 180, and that gives me $125,827.20. That was paid over the total of the 15 years. Now, the mortgage that started off with $85,000. That was the mortgage. So if I take the $125,000 minus the $85,000, you can see the total interest that was paid over those 15 years was $40,827.20. I know that's astonishing. It's a lot of money, and it's a little shocking. When you take out a mortgage, they are required to tell you this number of how much how much your interest is going to be over the life of the mortgage. There's ways that people can get around spending all of that money on interest. One of the ways is to make less payments. So maybe instead of 15 years, you end up paying it off in less time, so it could be less years. The other way is to make less payments. Instead of 180 payments, you know, sometimes people will pay like 13 payments a year to try to pay it off sooner, because then the interest won't be continually added as long. So you can, there's ways, of course, lowering your interest rate would lower the monthly payment, so that could be another way. So there's ways to try to decrease this number, but yeah, it's a lot of interest, I know. But it's good to know how to figure this out, where you take how many payments you're going to be making times the amount of the payment. You can see how much total money you're going to be paying back. Okay, so I'm going to pause again and see if there are any questions. If you have a question about something, you can type. You just click on the chat button, and then you can type something in the chat window and click the send button, and then I would see that question. Okay, I'm going to keep going then. I didn't see any questions in the chat window. The last thing that I wanted to take a look at with this financial math webinar is something called an amortization table. And this is where you're looking at each month, what happens to the money? Where is the money going? You are making this payment of $699.04. Where is that money going when it comes to your $85,000 mortgage? So here are the 3 steps for determining that. And that is, first, you need to find how much interest are you charged for that particular month. And then you're able to see how much of your payment goes toward the principal, and then you'll get the new balance of what you owe. So what this is doing is we're finding the interest being charged first, because the bank always gets paid first, and your principal gets paid second. So when you make a monthly payment, the bank gets their cut first, which is going to be whatever interest was charged that month. Then whatever's left over from that payment goes to the balance of the loan, and then you can see what the new balance is. Okay, so to find the interest charge just for the month, we can use this regular I equals PRT interest formula, and my principal, $85,000. We're going with the same example. $85,000, interest rate's the same, but notice I put 1/12 for T, and that's because T is in years. But we want 1 month. So 1 month is 1/12 years, because T is in years. Okay, so that is why for 1 month it's 1/12. Okay, so I'm going to put the numbers into the formula. There's my principal, my interest rate, and my time. I equals PRT. That gives me $396.67. So that is the interest that is being charged for the first month of this mortgage. So when you make the payments of $699.04, the bank is going to get $396.67. They take their money first, then whatever is left over, okay, so they take their money first, the $396.67 goes to the bank, and what is left over is the $302.37. So the $396.67 goes for interest, and the $302.37 goes to principal. So after the first month, you take the $85,000 that you owe, subtract the $302.37, and now you owe $84,697.63 after the first month. We're going to do this for 3 months, see what happens. So when we do this for month number 2, the principal is not going to be $85,000 anymore. This is the new principal balance. That is what we're going to use for P when we do this for the second month. Everything else stays the same. We're still using I equals PRT. The rate and the time are still the same, but notice the principal now is smaller because we made a payment last month. So here's my PRT from before to figure out how much interest I'm being charged for the second month, $395.26. So when you make your second month payment of $699.04, the $395.26 goes to the bank. They get their money first. So we're going to subtract to see how much is left over. $303.78 is left over to go toward your balance. Okay, so the $395.26 is for interest. The $303.78 is for principal. So going into the second month, you owe $84,697.63, and then your payment lowered it by $303.78. So now you owe $84,393.85. So this is the new balance after the second payment. That is now your new balance of the loan. So when we go into the third payment, this is going to be the number I use for P, for going into the third payment. So here's for the third month, there's my P of $84,393.85. The R and the T numbers don't change. I use my I equals PRT, multiply those together. For the third month, the interest charge is $393.84. So when you make your payments of $699.04, the bank gets their money first, $393.84. So what you have left is $305.20 to go toward what you owe on the mortgage. So going into the third month, you owe $84,393.85. Then your payment reduces that amount by $305.20. So now you owe $84,088.55 at the end of the third month. That's what you owe. So what an amortization table does is it takes all this and organizes it so it's easy to look at it in a table format. Okay, so you have, this is just the first 3 rows. Normally a table like this would go all the way down, like this mortgage was for 180 payments. The full table would go all the way down to payment 180, but didn't want to do that in this webinar, okay? We're just going to do the first 3 so that you can see how this works. So payment number 1, these are all the numbers we just calculated. That for the first payment, what the interest was, what the principal was, how much of the payment went to principal, and what the new balance, this is the new balance of the loan here in the last column. So after the first payment, there's your new balance, $84,697.63. Then after the second payment, we found the new balance was $84,393.85. Then after the third payment, $84,088.55. And like I said, this would continue all the way down to payment 180 until the principal balance is 0. Notice how the interest payments every month is decreasing because we are finding the interest by using this I equals PRT, and the principal keeps decreasing. So since the principal keeps decreasing, the interest is decreasing. And so notice how then this principal payment column is increasing because less of your money is going toward interest, so more of it can go toward the principal payment. And of course, the balance is decreasing. The principal balance of the loan is also, we could call that decreasing column, which is what you want because eventually it will be 0. Okay, so at the beginning of an installment loan, normally a big chunk of your payment is going to pay interest. And then as time goes on, less and less of your money goes to pay interest. You're still paying the same monthly payments every month, but it's how your money is divided up that changes from month to month. And how some people pay off loans sooner is that possibly pay extra onto the principal every month. So if you mark and say, I want this amount of money in addition to my regular payment going toward principal, then it will go toward decreasing this column. But you normally have to specify that. Otherwise, they'll just say, oh, good, they paid next month early. We'll count it toward that and take their interest off the top. So you need to always clarify, make sure that if you're going to pay extra because you want that principal balance to go down, that you specify it's meant for that purpose, especially with mortgages. So that gives you an overview of that type of table. And that brings us to the end of the agenda that I had set out for today, but I didn't know if there were any questions that I could address at this time. Anyone having calculator questions or questions about anything that pertains to financial math, you can type in the chat box. You just click on the chat on the right-hand side, and there'll be a little box that comes up. And so then you click in there and type, and then click the send button. You can send it to all attendees, or you can send it to, and I see there are questions. If you have a question, could you type it in the box? I see there are a couple of questions. I'll give a minute to allow that. Okay. It says, you stated earlier to reduce your interest rate, you should make payments earlier or pay off sooner. You mean to, okay, here's the question. To reduce your interest rate, you should make payments earlier or pay off sooner. To reduce how much total interest you're paying, I think that's what you're asking about. If you pay it off earlier, what happens is this column here hits 0 faster. So if you pay more money every month, then you're getting this to 0 faster. So because every month they calculate how much interest you owe, and when you make the payment, they get the interest first, and then the rest goes towards the balance. So one way to reduce how much interest you pay is to pay more on the principal balance, so then you will pay it off sooner. If you pay it off sooner, there's, you know, instead of 180 months of paying it back, you might only pay back 150 months. So the bank only has 150 opportunities to charge you interest instead of 180 opportunities to charge you interest. So you will be paying it off quicker if you pay it off. You know, if you pay more toward the principal balance, then you would pay the mortgage off quicker and save a ton of interest. If you, you can even find tables like this online. If you just do a Google search for amortization tables, it'll ask you like, what's the monthly payment, how many years, and it'll tally the total interest for you, and you can see what a difference it makes if you reduce the number of years. You know, you might have to pay a little higher every month, but it allows you to reduce the number of years by even just 1 year. It can make a big difference in how much interest you pay. So making payments, like 13 payments a year, for instance, it's like 1 month if you're making a double payment, then you can say, okay, that extra money goes toward principal balance, so you're getting that number smaller quicker, and the bank has less opportunity to charge you interest. I hope that answered your question. Other questions? I see question marks. If an attendee asked a question, but I don't see it in the chat box. Okay. If you have a question, feel free to type it in the chat. I don't want to end it because it looks like some people have questions. Maybe, if you click on the chat box, make sure you click send. You have to type in the chat box and then click the send button, or I won't see it. One thing I forgot to mention is my name is Christina Houston, and I didn't forget to mention that. But if you want to email me, it's CK. No, I just got married, so. I believe my email address, like I said, I just got married, so it's new. ckhouston1@liberty.edu. Thank you so much for putting up with my chicken scratch. I'm writing with my finger, so that's easier said than done. That's a 1. All right, I see more people with questions. Can you type your question in the chat box? Click on the chat on the right-hand side, and there'll be a chat box that comes up, and you click in the box and then type what your question is and click send. And then I can see your question. I'll wait just another minute here. If you have any questions, or maybe you can email me. I'm going to switch to my, well, no, I don't want to do that while I'm sharing my desktop. When sending a question, should an attendee press your name? Oh, you can click attendees, or you can click host and presenter, or all participants. You don't have to necessarily select my name, because if you do like host and presenter, I'm the host, or if you do all attendees or send to, if you send to all attendees, then everybody in the class would see. if you select an attendee, you can select. I don't think my name's on there because I'm considered the host, so you might not get. If you can select all participants, though, if you select all participants, I would see it. So I'll give another minute here for someone to type in their question. I do appreciate you logging in and listening to this. I hope it was helpful when it comes to the financial math part. I know the big formula, sometimes people get scared of the big formula. Sometimes people don't know which formula to use or how to type it in the calculator, or like I mentioned before, round before the very last step so your answers are all a few pennies off, and then I get emails from people saying, there's something wrong with my calculator. I keep getting answers that are a few cents off. So, you know, I'm hoping to avoid that type of frustration with the webinar. Okay, here's the question. In Math 115, is this the biggest part of this math? Well, in Math 115, I think I understand what you're asking there. You're asking, is this a big part of the course? It is, I'd say maybe a third of the course, maybe a little bit less than a third of the course is financial math. It incorporates a lot of different topics throughout the course, and it's almost like each unit is a completely different math topic, because it's math for liberal arts, so it doesn't take one area of math and go in depth. Like, this is not a financial math course, it's a math for liberal arts course, so financial math is one part of MAT 115. And this is about the time of the semester when MAT 115 students start hitting the financial math formulas and trying to figure out how to work with those formulas. So I think I answered that question. Okay. Well, like I said, I want to thank you for coming. I do need to wrap this up. If you have questions, feel free to email me, or you can email your MAT 115 instructor, because they know all of the same information about how to use the formulas and all of that. So, you know, I realize that there's more than just my students listening in, that there are other students as well with other instructors, which is great. So, you know, reach out to your instructor. You can send me an email if there's anything that you have a question about. And I want to thank you for participating. I'm going to go ahead and stop the recording, and this will be up for others to view who were unable to attend tonight. So thank you very much.